Good morning. So sorry this has to be a lesson video with the PSAT going on and everything in an 18-minute block. I thought this would be better than trying to rush through the lesson and leaving everyone confused. So I'm just going to go through these notes, and that way you can kind of follow along at your leisure, and I'll give you a hard copy so you can do the notes on the piece of paper while I'm going through the video. But this lesson is something that everyone should be familiar with, and it's all about slope. Finding slope, graphing lines, writing equations of lines, parallel and perpendicular lines, but the big idea is slope throughout this whole lesson. And the first form we're going to talk about is something you're all familiar with, but that's slope-intercept form. And so if you remember, slope-intercept form is y equals mx plus b. And in this form, if you remember, m stands for slope, and b stands for the y-intercept. Okay? So for this first section, it says identify the slopes of the following lines. So you look at A, and this is already in slope-intercept form, and so you can see that the slope is the number in front of x, so we would say the slope is negative 5. But if you look at B, that's not in slope-intercept form. So anytime you want to identify the slope of a line, you want it in slope-intercept form. So on B, we need to get y by itself. So first, let's subtract 5x to the other side. So negative 2y equals negative 5x plus 4. So we moved 5x over, bring down the negative 2y, and then divide everything by negative 2. And keep in mind, we're getting it into slope-intercept form to identify the slope. So I have negative 5 over negative 2, that becomes a positive 5 halves. Two negatives don't make a super negative, they make a positive. But we need to make sure we answer the question, so now I can see that the slope of this line would be 5 halves, so m equals 5 over 2. Okay. The next two lines are a little different. We have y equals 4 and x equals 5. So I'm going to just take a second and think about what you think the slopes of these lines would be. Okay, so the line y equals 4, if you graph it, it's going to cross the y-axis at 4. It's going to be a horizontal line. It's going to cross the y-axis at 4. And every single horizontal line in the world has a slope of 0. So the line y equals 4, the slope of that line would be 0. Every horizontal line has a slope of 0. And a little mnemonic device, you can turn any horizontal line into a z for 0. Now the line x equals 5, if you graph that, you get a vertical line. That's crossing the x-axis at 5. That would be this line right here. And every vertical line in the world has a slope that's undefined. So for this one, we would say m equals undefined. Every vertical line has an undefined slope. And the mnemonic device for this, you could turn an vertical line into a u for undefined. So you have z for 0, u for undefined. Okay. Now we're going to work on graphing a little bit. So this says graph the following lines. Alright. So we're going to use our slope-intercept techniques to graph this line. And if you remember, when you graph a line, make your own little coordinate plane here. You graph the y-intercept first, so that plus 1 goes on the y-axis at 1. And then from there you use your slope, which is negative 3, or negative 3 over 1. So from that y-intercept we go down 3 over 1 to the right. And we have a line that should be going downhill from left to right. Some teachers will have you put a whole bunch of points, but really to graph a line you only need 2. So once you plot the y-intercept and use your slope to get another point, you're done. Just draw the line and you're good to go. Well, now we have one in standard form. We don't have y by itself. So my advice is, if you have an equation that's not in standard or not in slope-intercept form, get it there. And we'll talk about other ways to go about this in a little bit, but for right now, let's just get y by itself. So subtract x. So 4y equals negative x plus 8, and then divide everything by 4. So y equals, now keep in mind what this first fraction means, there's a 1 in front of the x, so that'd be like negative 1/4 x plus 2. And so when we graph that, we put our y-intercept at 2. So y-intercept at 2. And then we use our slope of negative 1/4. So from that y-intercept, we go down 1, right 4. And we can draw our line. And there you go. Alright, next one we already talked about a little bit. If you're going to graph an x equals line, well, we know it's going to have undefined slope. We know it's going to be a vertical line, and it's crossing the x-axis at -2. So we put a point on the x-axis at -2, and we draw a vertical line. Right there. Alright. So that is how you can find the slope given an equation. That's how you can graph a line given an equation. But what about, and you've learned this before, what if I ask you to find the slope of a line that contains 2 points? So I say, here's 2 points from a line. Find the slope of that line. In option 1, you could say, well, you could draw a graph, plot those points, and count rise over run. But if you're going to do that in every one, it's going to take some time, and even more so if the numbers are gigantic. So there's a formula that you guys have learned. It's the slope formula. And it says m equals y2 minus y1 over x2 minus x1. You subtract your y's on top, your x's on bottom, and essentially this is finding rise over run. When you subtract the y values, you're finding how much up or down it changed. You're finding the vertical change. And on the bottom, when you subtract your x's, you're finding the horizontal change, or the run. Now, when you do this, it doesn't matter what order you subtract the y values. You can either do 3 minus 2 or 2 minus 3. That doesn't matter. But what does matter is you do the x's in the same order you did the y's. So when I'm going to do this, I'm going to subtract the y's on top. So I'm going to do 3 minus 2. And then on bottom, I'm going to do 4 minus -8, which becomes 4 plus 8. So I get 1/12. So there's your slope formula. You have the change in y over change in x. And it doesn't matter what order you subtract the y's, you just got to make sure you do the x's in the same order. So we come over here and we're going to find the slope. And so we're going to do 5 minus -2 over 4 minus 4. Subtract the y's over the x's. So we get 7 over 0. But we're not going to leave that as our final answer. You can't divide by 0, so think about what that means in terms of slope. We have 2 weird slopes. Well, actually, you only have 1 weird slope that's undefined. And that's what this is. You can't divide by 0, so the slope is undefined. If you had something like 0 divided by 7, you would actually simplify that and put 0. So there's a difference between having a 0 on top and a 0 on bottom. I know some of you have the phrase no slope in your vocab. We're actually never going to use that phrase. It does go with undefined. Sometimes those are interchangeable. But to avoid any sort of confusion, we're just going to eliminate that from the vocab, and we're just going to say undefined slope instead of no slope. Okay. So now we're going to get into writing equations. So this should be familiar. Hopefully this is familiar to some of you. I've learned if you had Mr. Stewart, this may not have been familiar to you, but here's the thing. If I said there's a line and it has a slope of 3 and it has a y-intercept of 2, and I said write the equation of that line. So I gave you the slope, I give you the y-intercept, and I say write the equation. My hope is you would just say, oh, y equals 3x plus 2. But oftentimes, you're not going to get this value. A lot of times, you're not going to get the y-intercept. You're going to have to find it. And so there's another form, and it's called point-slope form that we're going to focus on. And this is a huge, huge form when you get to pre-calculus, when you get to calculus. This one is used so often that it is important that you know it and know how to use it well. And it's very beneficial. And point-slope form is this. It's y minus y1 equals m parentheses x minus x1. You use this form instead of slope-intercept anytime you know the slope of a line and any other random point from the line. It doesn't have to be the y-intercept. If you know any other point from the line and the slope, you can use this form. And what happens is, you're going to replace 3 of these letters with numbers. M is obviously going to be where slope goes, but you're going to replace numbers for x1 and y1. That's the point that you know. Y and x are not going to change. Those are going to be left alone. But you're going to put numbers in for m, x1, and y1, and then we'll go from there and we'll convert it to slope-intercept. Okay? So let's take a look at how we use this. can't find the eraser button. They changed to explain everything, and now I can't find it. Okay, so it says, write the equation of a line that contains the points 5, -1, and -5, 5. So I want my final answer to be in slope-intercept form, but we don't know the y-intercept. This is where point-slope form comes in handy. Well, my advice is, anytime you're writing the equation of a line, if you don't know the slope, find it. And so we don't know the slope. Let's find the slope first of this problem. So we're going to do 5 minus -1, subtract the y's on top, and then -5 minus 5 on bottom. Just watch your signs. So you get 6 over -10, which is -3/5. There's the slope. To use point-slope form, you have to know one other point, 1 point from the line. And this problem's nice enough, they give you 2. But we don't need 2, we only need 1. So you get to pick the point you use. We're going to use this slope we found and pick one of these 2 points. It doesn't matter. So we'll just pick this point. And so there's the x1, y1 right there that we're picking. And so here's how we use point-slope form. It's going to be y minus the y-coordinate. So in this case, -1. So if you're doing y minus -1, that becomes y plus 1 equals -3/5 parentheses x minus 5. So notice what got plugged in where. Here's the y-coordinate, here's the x-coordinate, here's the slope. To convert this to slope-intercept now, we do 2 things. We distribute the slope, so we're running out of room here. We get y plus 1 equals -3/5 x. And then when I multiply -3/5 and -5 together, we get +3. The 5's cancel and you just get 3, and 2 negatives make a positive. And then subtract 1. And so you get y equals -3/5 x plus 2. So we didn't know the y-intercept, now we found it. I know some of you have learned you just use slope-intercept form to find b, but like I said, when you get to pre-cal, when you get to calculus, oftentimes answers, when you do take multiple choice stuff, answers are left in point-slope form, like you don't simplify. And so just get comfortable using this, even if you know another way. Get familiar with that slope, that point-slope form. The last thing we're going to talk about is parallel and perpendicular lines. Now obviously you know what they look like. Parallel lines never cross. But more importantly, what do you know about their slopes? What do you know about slopes of parallel lines? Well, parallel lines, the slopes are equal. Because slope means steepness. And if you have 2 lines that are parallel, they have the same steepness. So the slopes are equal. Perpendicular lines, however, form a right angle. Their slopes are not equal. They have a special relationship, though, and try to think about if you know what that is. Their slopes are what we call opposite reciprocals. Opposite reciprocals. That means if one line has a slope of, let's say, 2/3, the other one would have a slope of -3/2. So opposite means the sign changes, reciprocal means the fraction flips. So both things have to happen for lines to be perpendicular. And let's use those 2 pieces of information to answer the last 2 questions from the notes. So example 5 says, write the equation of a line that's parallel to the given line, parallel to this one, and contains the point 3, -5. Okay, so I want a line parallel to the one they give us, which means it would be useful to know the slope of the line they give us. So let's identify the slope of the line they give us first. So we need to put it in slope-intercept form. So let's move 4x to the other side, and it's going to become negative. And then divide everything by 2. So right now we're trying to find the slope of the line they give us, and that slope is -2. Well, I want a line that's parallel to this one. And so think, if they're parallel, their slopes are going to be the same. So if this slope is -2, then I want a line that has a slope of -2 and contains this point over here. So I'm going to put the information by each other. I like to put the slope and the point next to each other. And now we know a point from the line, the slope of the line, so we're going to use our friend the point-slope form. So it's y minus the y-coordinate, so y minus -5, so y plus 5, equals the slope, and then x minus the x-coordinate. And then 2 steps. Distribute, and subtract 5. Y equals -2x plus 1. So that's the line that's parallel to the one they gave us. Notice the slopes are the same, but they have different y-intercepts because they're crossing different points. They're at 2 different places. All right, last one. Write the equation of the line that's perpendicular now, perpendicular, so the slopes won't be the same, to y equals 3/4 x minus 2 and contains the given point. So the slope of the line they give us is 3/4. I want a line perpendicular to this, so the opposite reciprocal of 3/4 is -4/3. So I'm going to use that point and that slope and use point slope form. So y plus 2 equals the slope, and then x minus 6. Y plus 2 equals -4/3 x. Now let's multiply -4/3 and -6 together. That becomes a positive. And then 4 times 6 is 24, divided by 3 is 8. And then subtract 2. Alright, so that's everything there is to know about the first section in terms of finding slope, graphing lines, vertical, horizontal, undefined slope, writing equations, parallel and perpendicular. That's a lot of stuff in one lesson, but it is stuff you hopefully are familiar with already. But what's nice about it, I made a video because I know it is kind of fast. If you need to go back and look back over something, by all means, please do. But hopefully that was beneficial, and let me know if you have any questions. Peace.